To understand load calculations for heat pump systems, it is essential to know how to convert between different units of power and energy. This explanation focuses on converting kilowatts, abbreviated as kW, to BTU per hour, which stands for British Thermal Units per Hour. This conversion is particularly useful when dealing with heat pump systems, as their capacity is often expressed in either kilowatts or BTU per hour. A conversion table for load calculation shows the conversion between BTU per hour, tons of refrigeration, and kilowatts. Firstly, for BTU per hour, divide by 3.412. Secondly, for tons of refrigeration, multiply by 3.517. Thirdly, for kilowatts, no conversion is needed. To convert from BTU per hour to kilowatts, you would divide the BTU per hour value by 3.412. Conversely, to convert from kilowatts to BTU per hour, you would multiply the kilowatt value by 3.412. Let's consider a specific example: a 20 kilowatt heat pump system. To determine its equivalent capacity in BTU per hour, we use the following formula: BTU per hour equals kilowatts multiplied by 3.412. In this case, BTU per hour equals 20 kilowatts multiplied by 3.412. Performing this calculation, we find that BTU per hour equals 68,240 BTU per hour. Therefore, a 20 kilowatt heat pump system has a capacity of 68,240 BTU per hour. It is important to note that this conversion factor of 3.412 is specific to converting between kilowatts and BTU per hour. When dealing with other types of equipment or energy conversions, different conversion factors may apply. For example, converting tons of refrigeration to kilowatts or BTU per hour would require a different factor. A ton of refrigeration is a unit of power used to describe the cooling capacity of air conditioning and refrigeration systems. 1 ton of refrigeration is defined as the amount of heat required to melt 1 ton, which is 2,000 pounds, of ice at 32 degrees Fahrenheit over a 24-hour period. This is equivalent to 12,000 BTU per hour or 3.517 kilowatts. When performing load calculations, it's crucial to use the correct conversion factors to ensure accurate results. This is especially important for determining the appropriate size of heating and cooling equipment for a given space. An undersized system may not be able to adequately heat or cool the space, while an oversized system may lead to energy waste and reduced efficiency. The basic formula to convert kilowatts to BTU per hour is BTU per hour equals kilowatts multiplied by 3.412. This formula arises from the definition of a BTU and its relationship to other units of energy. A BTU is the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. A kilowatt is a unit of power equal to 1000 watts, and it represents the rate at which energy is used or produced. The conversion factor of 3.412 reflects the relationship between these units. In the context of heat pump systems, the kilowatt rating typically refers to the electrical power input to the system, while the BTU per hour rating represents the heating or cooling output of the system. The heat pump uses electrical energy to transfer heat from one location to another, either heating or cooling the space. The efficiency of a heat pump is often expressed as its coefficient of performance, abbreviated as COP, or its heating seasonal performance factor, abbreviated as HSBF for heating, and seasonal energy efficiency ratio, abbreviated as SEER, for cooling. These ratings indicate the amount of heating or cooling output the system can provide for each unit of electrical energy input. When performing load calculations for a building or space, it is important to consider various factors, such as the size of the space, the insulation levels, the number of windows, the climate, and the occupancy. These factors can all affect the amount of heating or cooling required to maintain a comfortable indoor environment. Accurate load calculations are essential for selecting the appropriate size of heating and cooling equipment and for optimizing energy efficiency. In addition to converting between kilowatts and BTU per hour, it may also be necessary to convert between other units of energy or power, such as watts, horsepower, or joules. There are various online calculators and conversion tables available to assist with these conversions. It is important to use reliable sources and to double-check the results to ensure accuracy. When working with electrical systems, it is also important to follow all safety precautions and to consult with a qualified electrician if necessary. Electrical work can be dangerous, and it is important to take appropriate measures to protect yourself from electric shock and other hazards. Understanding the conversion between kilowatts and BTU per hour is a fundamental aspect of working with heat pump systems and performing load calculations. By using the correct conversion factors and formulas, it is possible to accurately assess the heating and cooling requirements of a space and to select the appropriate equipment for the job. This knowledge is essential for optimizing energy efficiency and ensuring a comfortable indoor environment. The specific formula to convert the 20 kilowatt heat pump system to BTU per hour is BTU per hour equals 20 kilowatts multiplied by 3.412, which results in 68,240 BTU per hour. Remember that this conversion is specific to heat pumps and that different conversion factors may apply to other types of equipment. For example, if you were working with an electric resistance heater, the conversion factor would be slightly different due to the different way in which these devices generate heat. Electric resistance heaters convert electrical energy directly into heat, while heat pumps use electrical energy to transfer heat from one location to another. Another important consideration when performing load calculations is the diversity factor. The diversity factor is a ratio that represents the proportion of the total connected load that is likely to be in use at any given time. For example, if you have multiple appliances or pieces of equipment connected to the electrical system, it is unlikely that all of them will be operating at the maximum power draw simultaneously. The diversity factor takes this into account and allows you to reduce the overall load calculation accordingly. The diversity factor can vary depending on the type of load and the specific application. It is important to consult relevant codes and standards to determine the appropriate diversity factor for a given situation. In addition to the diversity factor, it is also important to consider the demand factor. The demand factor is similar to the diversity factor, but it represents the ratio of the maximum demand of a load to its total connected load over a specified period of time. The demand factor is typically used for calculating the size of electrical service equipment, such as transformers and circuit breakers. When performing load calculations, it is important to use accurate and reliable data. This includes information about the power consumption of various appliances and equipment, as well as data on the climate and building characteristics. Using inaccurate data can lead to significant errors in the load calculations, which can have serious consequences. In some cases, it may be necessary to perform detailed energy modeling to accurately assess the heating and cooling requirements of a building or space. Energy modeling involves using computer software to simulate the energy performance of a building under various conditions. This can provide valuable insights into the energy consumption patterns of the building and help to identify opportunities for energy efficiency improvements. Load calculations are an essential part of electrical engineering and HVAC design. They are used to determine the appropriate size of electrical service equipment, heating and cooling equipment, and other building systems. Accurate load calculations are critical for ensuring the safety, reliability, and energy efficiency of buildings. When performing load calculations, it is important to follow all applicable codes and standards. These codes and standards provide guidance on the proper methods for calculating loads and selecting equipment. They also help to ensure that buildings are designed and constructed in a safe and efficient manner. In addition to the technical aspects of load calculations, it is also important to consider the economic aspects. The cost of electrical service equipment, heating and cooling equipment, and other building systems can be significant. It is important to carefully evaluate the costs and benefits of different design options to ensure that the most cost-effective solution is selected. In some cases, it may be possible to reduce the load on the electrical system or the heating and cooling system by implementing energy efficiency measures. This can help to reduce the initial cost of the equipment, as well as the ongoing operating costs. Energy efficiency measures can include things like improving insulation, installing energy-efficient windows, and using energy-efficient lighting. Load calculations are a complex and multifaceted topic. However, by understanding the basic principles and following all applicable codes and standards, it is possible to perform accurate load calculations and design buildings that are safe, reliable, and energy efficient. Remember that the conversion factor of 3.412 is specifically for converting between kilowatts and BTU per hour. For other conversions, such as tons of refrigeration to kilowatts, different factors will apply. It is always important to double-check the conversion factors and formulas that you are using to ensure accuracy. By applying the formula BTU per hour equals kilowatts multiplied by 3.412, you can easily convert the kilowatt rating of a heat pump system to its equivalent BTU per hour capacity. This information is valuable for understanding the heating or cooling output of the system and for performing accurate load calculations. Consider a scenario where a building owner is considering installing a new 25 kilowatt heat pump system. To determine the equivalent BTU per hour capacity, the calculation would be BTU per hour equals 25 kilowatts multiplied by 3.412, which equals 85,300 BTU per hour. This information can then be used to compare the capacity of the heat pump system to the heating and cooling requirements of the building. Remember that accurate load calculations are essential for selecting the appropriate size of equipment and for ensuring that the building is adequately heated and cooled. Load calculations should take into account various factors, such as the size of the building, the insulation levels, the number of windows, the climate, and the occupancy. A comprehensive load calculation will provide a detailed estimate of the heating and cooling requirements of the building under various conditions. Load calculations also help in determining the appropriate size of the electrical service equipment, such as the transformer and the service panel. The electrical service equipment must be sized to handle the maximum demand of the building, which is determined by the load calculations. An undersized electrical service can lead to overloaded circuits and potential safety hazards, while an oversized service can be unnecessarily expensive. It is therefore important to perform accurate load calculations to ensure that the electrical service is properly sized. In addition to the heating and cooling loads and the electrical loads, load calculations can also include other types of loads, such as lighting loads, appliance loads, and equipment loads. Each type of load must be carefully considered to ensure that the load calculations are comprehensive and accurate. The results of the load calculations can then be used to design the building systems and to select the appropriate equipment. The goal is to create a building that is safe, reliable, energy efficient, and comfortable for the occupants. Accurate load calculations are a critical step in achieving this goal. Always consult with qualified professionals, such as engineers and electricians, to ensure that load calculations are performed correctly and that the building systems are designed and installed in accordance with all applicable codes and standards. Working with qualified professionals can help to avoid costly mistakes and to ensure that the building is safe and efficient. Consider the application of this conversion factor in real-world scenarios. For example, an HVAC technician may need to determine the BTU per hour output of a heat pump system to properly size ductwork or to diagnose a performance issue. By using the formula BTU per hour equals kilowatts multiplied by 3.412, the technician can quickly and easily convert the kilowatt rating of the heat pump system to its equivalent BTU per hour capacity. This information can then be used to make informed decisions about the system's design and operation. Similarly, an electrical engineer may need to determine the kilowatts input of a heat pump system to properly size circuit breakers or to calculate the energy consumption of the building. By using the reverse of the formula, kilowatts equals BTU per hour divided by 3.412, the engineer can easily convert the BTU per hour rating of the heat pump system to its equivalent kilowatt input. This information can then be used to make informed decisions about the electrical system's design and operation. Understanding the relationship between kilowatts and BTU per hour is essential for anyone working with heat pump systems. By mastering this conversion, you can improve your understanding of these systems and make more informed decisions about their design, installation, and operation. For a 20 kilowatt heat pump system, the conversion to BTU per hour yields 68,240 BTU per hour, demonstrating the direct application of the kilowatt to BTU per hour conversion formula.